Welcome, dear stargazer, to the sleepy astronomer, where the mysteries of the cosmos drift softly through your mind like clouds across a moonlit sky. I'm so glad you're here. As we begin our journey tonight, take a moment to settle in. Maybe you're lying down, wrapped in a warm blanket, or listening with the gentle hum of the evening all around you. Wherever you are in the world, whether it's a quiet countryside, a bustling city, or somewhere in between, let me know in the comments where you're watching from. It's always a joy to see how far this little universe of ours reaches. Now close your eyes if you'd like, and let's explore how the universe keeps time. In the beginning, there was silence, no ticking, no heartbeat, no breath. Time itself did not yet exist, not as we know it. Then, in an instant so brief and so immense, the universe was born. A singularity erupted in what we now call the Big Bang, a name too small for something so vast. Out of nothing came everything: light, matter, space, and time. This moment wasn't just the beginning of stars or galaxies, it was the birth of time's very flow. Before this expansion, the concept of before may not have even made sense. There was no then to precede it. And as the universe unfurled in all directions, expanding like a balloon slowly filling with air, the first seconds began to pass. At first, time was tangled with space, temperature and pressure in a chaotic dance. The universe was unimaginably hot and dense, filled with pure energy and the seeds of all that would come. In these earliest microseconds, time moved rapidly, but not in a way we could yet measure. There were no clocks, no suns, no turning planets. Just energy cooling, spreading, stretching toward complexity. As fractions of a second turned into full seconds, the first particles formed, quarks and electrons zipping through space like flecks of light caught in a storm. Soon after, those particles bound together to form protons and neutrons. Still, time kept moving. Not ticking in the mechanical sense, but flowing, unfolding. Every heartbeat of the universe brought more structure. Minutes passed, and hydrogen was born, the simplest element, and the building block of stars. But it would be hundreds of millions of years before those stars ignited. Still, time moved forward. The universe, though dark and silent, was steadily marching through epochs of its own design. As expansion continued, gravity began to weave its influence. Matter clumped together, slowly, patiently, like dew gathering on blades of grass in the early morning. Over eons, gravity would pull gas into great clouds, clouds into denser knots, and eventually, stars would ignite. The ignition of the first stars brought a new rhythm to the cosmos. Light filled the darkness, and with it came the possibility of more complex patterns, cycles, orbits, and pulsations. Time, once formless, began to take on rhythm and recurrence. These celestial patterns would one day be our natural clocks. But all of this, stars, galaxies, planets, even the concept of a day or a year, came long after that first incredible moment. That single event, that great eruption of being, is what set the arrow of time in motion. From then on, the universe would never be still again. It would stretch, evolve, and change. Stars would be born and die. entire galaxies would collide and reshape. And through it all, time would continue its silent flow, unseen, unfelt, but always there. Even now, we are riding the wave that began in that ancient moment. Every breath you take, every blink of your eyes, is part of this vast, continuous unfolding. We measure time in seconds and minutes, but the universe knows no such boundaries. Its clock is made of expansion and entropy, of gravity and light, of change itself. And so, the cosmic clock began, not with a tick, but with a burst. A quiet birth of movement from stillness. A pulse that has never stopped. Long before humanity had calendars, clocks, or even written language, there was the moon. Hanging silently in the sky, it has watched over the earth for billions of years, casting its silvery glow across oceans, deserts, and forests. It is one of the most ancient companions of our planet, and one of the first timekeepers known to humankind. When early humans looked up at the night sky, they saw more than stars. They saw a glowing orb that changed shape night after night, in a slow and mysterious rhythm. Sometimes it was a sliver, like a fingernail cut from the dark. Other times it was a perfect glowing disk, full and luminous, shining with a soft light that could guide travellers and stir the tides. Then it would begin to vanish again, shrinking until it was gone, only to reappear once more in a never-ending cycle. This waxing and waning of the moon was one of the first reliable patterns that early humans could observe. It took about 29.5 days to complete a full cycle, from new moon to full moon and back again. People began to mark time by this rhythm, tracking the phases and using them to predict when to plant seeds, when to harvest, and when to prepare for winter. Long before the invention of months or weeks, moon cycles formed the structure of early timekeeping. Some of the earliest calendars, scratched into bones or carved into stone, show a careful record of lunar phases. These people may not have had telescopes, but they had something just as powerful: attention. They watched, they remembered, and they passed their knowledge down through generations. In many cultures, the moon came to be seen as a divine or mystical presence, more than a rock in the sky. To the ancient Egyptians, it was Thoth, the god of wisdom and time. To the Greeks, it was Selene or Artemis, goddesses riding the heavens in glowing chariots. In China, the moon became a symbol of family reunion and reflection, celebrated with lanterns and mooncakes. And in many indigenous traditions across the world, the moon still holds sacred significance, guiding spiritual practices and storytelling. But beyond the myths and poetry, the moon plays a very real, physical role in regulating time on Earth. Its gravitational pull tugs gently at our oceans, creating the rise and fall of tides. These tides are not just natural rhythms, they're clocks too. In many coastal cultures, tides were used to track time as reliably as any sun or star. Fishermen and sailors depended on them, and so did the animals of the sea. The moon also stabilizes the Earth's tilt, which is crucial for our seasons and the overall climate. Without it, our planet might wobble unpredictably, making time as we know it far more chaotic. Thanks to the moon's silent companionship, Earth's movements are more regular, more predictable. another way it quietly keeps time for us. Even now, in the modern age, the moon continues to guide us. Its cycles are baked into our calendars, our religious festivals, and our biology. Many people still feel the pull of the full moon, sensing a change in mood or energy. Some sleep less during its brightest phase. Others feel a strange restlessness, as though something ancient inside them remembers how long we have watched that glowing sky. In our technology-filled world, it's easy to forget that we once counted the passing of time, not by numbers or buzzing alarms, but by simply looking up. The moon was our guide. It didn't tick or beep. It glowed. It changed shape. And it returned, always, in its quiet loop through the heavens. Tonight, as you drift off to sleep, the moon may be shining outside your window, or perhaps it's hidden behind clouds or on the other side of the earth. But it's there, just as it has always been, moving through its cycle, gently turning the pages of time. Every morning, without fail, the sun rises. Its golden light spills across mountaintops, filters through trees, and slowly warms the surface of our turning planet. This daily rhythm, sunrise and sunset, is perhaps the most ancient and universal experience shared by every creature that walks, swims, or flies on Earth. Long before we understood the mechanics of our solar system, the sun's reliable appearance and disappearance became the most basic measure of time, the day. To our distant ancestors, the sun was more than just a source of light. It was life itself. Its warmth grew their crops, dried their clothes, and kept the cold of death at bay. They noticed how shadows changed length as the day passed, how the light shifted from bright white to golden amber, how even animals responded to the sun's movements. Birds sang at dawn, wolves howled at dusk, and flowers opened their petals to the light, only to close them again as night approached. In this simple, observable pattern, people found meaning and structure. Morning was a time of beginnings, of gathering food, of setting out on journeys, of lighting fires. Midday, when the sun was highest and shadows shortest, was often the time to rest, to seek shade, to pause. Evening marked the return home, the preparation for sleep, and the closing of the day's chapter. The rotation of the Earth on its axis, spinning once every 24 hours, is what creates this cycle of light and dark. Yet from our perspective on the surface, it feels as though the sun itself is moving, rising in the east, climbing across the sky, and setting gently in the west. This illusion shaped entire cultures and belief systems. Many ancient peoples believed the sun was a powerful deity riding through the heavens each day. The Egyptians revered Ra, the sun god, who sailed across the sky in a golden boat and descended into the underworld each night. The Aztecs believed the sun required sacrifice to keep moving, to continue its eternal journey, and prevent darkness from consuming the world. The importance of this daily solar rhythm cannot be overstated. In prehistoric times, early humans likely measured the passing of time by watching where the sun rose and set in the landscape. They used natural features like mountains, trees, or standing stones to mark its position at different times of the year. Over centuries, this casual observation evolved into intentional architecture, stone circles, temples, and monuments aligned precisely with the sun's movements during solstices and equinoxes. These structures, like Stonehenge or the pyramids of Egypt, were not just places of worship, they were solar calendars carved in stone. Beyond religious significance, the sun's daily cycle dictated practical matters. Farmers relied on it to plan their planting and harvesting. Nomads used it to navigate open landscapes. Builders timed their work to avoid the harshest heat. Even sleep and waking cycles were shaped by it. Human biology became entwined with sunlight. Our circadian rhythms, the internal clocks that govern sleep, hormone production, and energy levels are finely tuned to the rising and setting of the sun. We are in every sense creatures of daylight. Even as we entered the age of mechanical clocks and electric lights, the sun's influence never truly faded. The concept of a day remains rooted in the Earth's rotation and the sun's position in the sky. Our work schedules, our school hours, our rituals of breakfast, lunch and dinner, all are echoes of the solar rhythm. Cities may glow with artificial lights now, but the sun still rules the rhythm of the world. There's something deeply comforting about the sun's constancy. No matter how unpredictable life becomes, we can trust that the sun will rise again. It has done so every day for billions of years, casting its light over dinosaurs, empires, explorers, and dreamers. It shines today just as it did when the first human looked up and marvelled at its brilliance. As you listen to this now, somewhere in the world, the sun is rising, golden light touching the treetops, birds awakening with song, the sky shifting from deep blue to pale pink. And somewhere else, it is setting, drawing long shadows, cooling the earth, whispering that it's time to rest. This beautiful, endless dance of light and shadow has been the heartbeat of Earth since the beginning, and it will continue long after we are gone. So let yourself sink into that rhythm. Feel the peace of knowing the sun will rise again, and again, and again. Let it remind you that even in darkness, morning always comes. When night falls and the world grows quiet, a different kind of timekeeper emerges in the sky. The stars, scattered like glitter across the deep velvet of night, have always been more than just distant balls of burning gas. For thousands of years, they served as silent guides, ancient storytellers, and celestial clocks for those who watched them with patient eyes and wondering hearts. Long before electricity, before city lights painted the night with artificial glow, the stars were astonishingly vivid. Entire galaxies shimmered above villages, deserts, forests, and oceans. For ancient people, the sky was a living map, not just of space, but of time itself. As the Earth turned, the stars appeared to rise in the east and set in the west, just like the sun and moon. But unlike the sun, which follows a daily rhythm, the stars revealed longer, deeper patterns. They didn't just tell the hour, they told the season. People began to notice that certain stars and constellations only appeared at certain times of the year. The bright, distinctive shape of Orion would stride across the winter sky, but vanish in summer. The gentle glow of the Pleiades marked the beginning of planting season in some cultures. And when Sirius, the dog star, rose just before the sun in ancient Egypt, it signalled the coming of the Nile's life-giving flood. These were not coincidences. They were cosmic signals, rhythms written in light. By watching the stars and remembering their journeys, early astronomers could predict the changing of the seasons, the arrival of rains, or the best time to harvest. They had no need for metal clocks or paper calendars. The sky provided all they needed. Observing the constellations became a way to mark the passage of time, not just in days, but in months, years, and even generations. Some cultures divided the year into star-based months, or moons, while others built monumental structures aligned to the movements of particular stars. The Maya, for example, created astonishingly precise calendars by carefully observing the heavens. In Polynesia, wayfarers memorized the rising and setting points of stars to navigate vast oceans without any instruments, using the sky itself as a map and clock. In Arabia, nomads knew how many days had passed by which constellations were overhead during their travels across the desert. But it wasn't only practical. The stars inspired imagination too. People began to connect the dots between stars, forming pictures, constellations, and filling the night sky with stories. These sky stories were often tied to time as well. In Greece, the constellation Virgo, associated with the goddess of the harvest, would disappear as winter approached and reappear in the spring, a heavenly reminder of the cycle of planting and reaping. In China, the constellations formed part of a great celestial bureaucracy, with emperors, dragons, and messengers moving through the heavens just as events unfolded on Earth. Even today, long after satellites and atomic clocks have redefined our understanding of precision, astronomers still rely on the stars for keeping cosmic time. Certain stars, like Cepheid variables, actually change in brightness in regular, predictable cycles, blinking slowly and steadily like ancient lighthouses in the dark. These stellar pulses help scientists measure the size of the galaxy and even the age of the universe itself. And then there is the great wheel of the sky, the slow, majestic rotation of the heavens, known as the precession of the equinoxes. Over thousands of years, the position of stars shifts ever so slightly due to the wobble in Earth's axis. This means that even the sky's calendar is not entirely fixed. It changes over the span of millennia. What was once the North Star thousands of years ago is not the North Star today. And yet, this change itself is just another cosmic clock, an incredibly slow one, ticking across the ages. So when you lie beneath the stars and gaze upward, you're not just looking at points of light. You're looking into time. Some of that light has travelled for hundreds, thousands, even millions of years just to reach your eyes. You are witnessing the past. Stars that may no longer even exist, whose light still dances in the present sky. In a world that often feels fast and chaotic, the stars offer something different. Patience. Stillness. A rhythm too grand to rush. They remind us that time can be vast and slow and beautiful. That it's okay to measure life not only by seconds or deadlines, but by the steady return of constellations, by the comfort of a sky that repeats itself in cycles older than history. So the next time you find yourself looking up, whether from a mountaintop or your own backyard, remember the stars are keeping time, quietly, faithfully, just as they always have. From the earliest days of human curiosity, our ancestors sought ways to grasp the invisible flow of time. Without watches or clocks, they looked to the world around them, the sun, the moon, the stars, and devised ingenious methods to mark its passage. These ancient timekeepers, crafted from stone, water, and shadow, were humanity's first attempts to bring order to the endless rhythm of day and night. One of the most familiar of these ancient tools is the sundial. It may seem simple, just a stick casting a shadow on a flat surface, but it embodies profound understanding. As the sun arcs across the sky, the shadow moves steadily, pointing to hours and moments long before mechanical clocks existed. Early civilizations from Egypt to Greece to China created sundials in many shapes and sizes, often decorating them with inscriptions or artwork that linked time to mythology and spirituality. The sundial worked perfectly on sunny days, but what about the nights or cloudy skies? Ancient people developed other clever devices to measure time. Water clocks, or clepsydras, became an important solution. These devices measured time by the steady dripping of water from one container to another. Though simple in principle, water clocks required careful design to maintain a consistent flow. They were used in Egypt, Babylon, and later in Greece and Rome, allowing rulers to time speeches, rituals, and legal proceedings with surprising accuracy. Alongside these, there were other forms of early timekeepers: oil lamps with marked levels that burned at known rates, candles with evenly spaced markings that indicated the passage of time as they melted, and even incense sticks, carefully crafted to release fragrance over measured periods. Each method reflected a human desire to bring precision and predictability to daily life, to know when to rest and when to act, when the season was changing, or when sacred rituals should begin. Monuments and natural landmarks also served as gigantic calendars and clocks. Stone circles, like Stonehenge in England, stand as magnificent testaments to this ancient obsession with time. Built thousands of years ago, these massive stones align precisely with the sunrise and sunset on solstices and equinoxes, key moments in the solar year that marked planting or harvesting times for agricultural communities. The builders of Stonehenge and similar sites may not have understood the physics of orbits or gravity, but they had an intimate knowledge of the sun's path and how it related to life on Earth. Other cultures crafted enormous structures with similar purposes. The Mayan pyramids in Central America, for example, cast shadows that marked important calendar dates, while the ancient Egyptians built temples aligned to the rising of specific stars. These architectural marvels were not only places of worship or power, but also grand cosmic clocks, reminding people of the connection between Earth, sky, and time. This blending of astronomy, engineering, and spirituality shows that ancient timekeeping was never just about numbers or schedules. It was about understanding our place in the universe and the cycles that govern life. People saw time as a living force, something to be honoured, respected, and harmonised with. These early devices and monuments shaped daily life in profound ways. Farmers depended on them to know when to plant seeds so they wouldn't freeze or wither. Hunters and gatherers used them to track the seasons of migrating animals and ripening fruits. Even communities far from the sun's equator used these markers to plan festivals, rituals, and social gatherings, moments that wove people together across generations. As time passed and technology advanced, these ancient timekeepers were replaced by more precise tools. Mechanical clocks eventually took over, and with them came a new sense of time as something measured in equals, repeatable units. Yet the legacy of these early devices remains. Their slow, natural rhythms remind us that time is more than just minutes and seconds. It is cycles of nature, movements of the heavens, and the quiet pulse of life itself. In the stillness of the night, or the warmth of the sun, when you feel the steady turning of the world beneath your feet, remember that humans have been tracking time for thousands of years, long before watches or smartphones. They built sundials, water clocks, and stone monuments not only to measure the passing hours, but to connect with something far greater, a cosmic rhythm that has always been ticking softly, just beyond our sight. So as you rest, let the memory of these ancient timekeepers ease your mind. Imagine the slow drip of water marking an hour in a distant past, the shadow moving steadily across a stone, the gentle alignment of stones bathed in dawn's first light. These are the echoes of human wonder and patience, the first clocks in a universe that never stops turning. Beneath our feet, the earth is in constant motion. While this may seem invisible to our daily lives, this subtle but unending movement is the foundation of how we experience time itself. One of the most essential motions is the Earth's rotation, a steady spin on its axis that takes approximately 24 hours to complete. This rotation is what creates the cycle of day and night, and it is the invisible clock that governs life on our planet. Imagine the Earth as a slowly spinning top, tilted gently on its side as it pirouettes through space. This tilt, combined with the rotation, causes sunlight to sweep across the surface in a rhythmic dance, light chasing darkness in an endless loop. When your part of the world faces the sun, it is daytime, filled with warmth and brightness. When it turns away, night falls, cloaking everything in shadow and quiet. This rotation isn't just a simple spin, it is a finely tuned cosmic rhythm. Over millions of years, the Earth's rotation has gradually slowed down due to the gravitational pull of the Moon, a phenomenon called tidal braking. Long ago, a day on Earth was much shorter, lasting only a few hours. But over time, the Moon's gentle tug has stretched the day to the familiar 24 hours we know today. This daily spin has profound effects on life. Plants open their leaves to the sun and close them at night. Animals wake, hunt, rest and sleep following this cycle. Even our own bodies are tuned to this rhythm through the circadian clock, a tiny biological mechanism inside us that tells us when to be alert and when to rest. The Earth's rotation shapes this internal clock, syncing our sleep patterns, hormone releases and metabolism with the rising and setting sun. The idea of the Earth spinning was once controversial. For centuries, people believed the sun revolved around a stationary Earth. It took the bravery and insight of astronomers like Copernicus, Galileo, and Kepler to reveal the truth. It is the Earth that spins on its axis and orbits the sun. This revelation forever changed our understanding of time and place in the cosmos. The Earth's rotation also causes phenomena that remind us of its ceaseless motion. The apparent movement of the stars across the night sky is a result of this spin. The Coriolis effect, a consequence of rotation, influences weather patterns and ocean currents, shaping climates and ecosystems worldwide. Even the mysterious twirling of hurricanes and tornadoes is linked to this planetary spin. Humans have long used the Earth's rotation to mark time. The division of the day into 24 hours, the concept of midnight and noon, all stem from the Earth's steady spin. Ancient civilizations crafted sundials to track the sun's path across the sky, but fundamentally, it is the Earth's rotation that makes the sun appear to move. Interestingly, the Earth's rotation is not perfectly constant. Tiny fluctuations, called length of day variations, occur due to seismic activity, shifting winds, and changes in the distribution of water and ice across the planet. Scientists monitor these subtle changes using atomic clocks and satellites, which allows for precise timekeeping essential to navigation systems like GPS. When you feel the passage of a day, the gentle light fading to dusk and returning again to dawn, you're experiencing the result of this great cosmic spin. It connects all living things on Earth in a shared rhythm, a natural pulse that has persisted for billions of years. This rotation is a reminder that time is not merely an abstract concept, but something rooted deeply in the physical world and the dance of celestial bodies. As you drift towards sleep, imagine the Earth turning slowly beneath you, steady and sure, carrying you through night and day. Know that this great spin is the heartbeat of time on our planet, a quiet, powerful rhythm that never falters, never stops. It is the invisible clockwork of life, turning endlessly beneath the stars. Beyond the gentle spin of the Earth lies another grand motion, one that takes the planet on a majestic journey around the Sun. This journey, known as the Earth's orbit, is the reason we experience the changing seasons and the passing of years. It is a cosmic dance that unfolds over approximately 365 days, creating a rhythm that shapes life in profound and beautiful ways. Picture the Earth travelling through space, tracing a nearly circular path around the blazing sun. This orbit is steady and constant, a slow procession through the cosmic neighbourhood. As the Earth moves along this path, the tilt of its axis, the same tilt responsible for day and night, remains fixed in direction, pointing toward the distant North Star. This tilt means that different parts of the planet receive varying amounts of sunlight throughout the year, and this is what brings the seasons. When the northern hemisphere leans toward the sun, it basks in longer days and warmer temperatures. Spring and summer arrive. Flowers bloom, rivers swell with melted snow, and life bursts forth in vibrant colours. At the same time, the southern hemisphere tilts away, experiencing shorter days and the cooler months of autumn and winter. Half a year later, the roles reverse, and the cycle continues, spinning endlessly as Earth orbits its star. The marking of a year, the completion of one full orbit, became one of humanity's earliest ways to measure longer stretches of time. Observing the changing position of the sun and stars throughout the year allowed ancient peoples to create calendars, vital tools for agriculture, hunting, and celebration. The Egyptians aligned their calendar with the flooding of the Nile, which coincided with the heliacal rising of Sirius, while the Mayans built intricate calendars tied to planetary cycles and the sun's movements. The length of the year is not exactly 365 days. It's closer to 365.25 days. This fractional difference means that our calendar requires a little adjustment now and then to stay in sync with the Earth's orbit. That's why every 4 years we add a leap day, February the 29th, to keep the seasons aligned with our clocks. This orbit around the Sun is also responsible for the solstices and equinoxes, the key points that divide the year into seasons. The summer solstice marks the longest day of the year, when the Sun reaches its highest point in the sky. Conversely, the winter solstice is the shortest day, when sunlight is at its weakest. The equinoxes, spring and autumn, are moments of balance when day and night are nearly equal in length. These celestial milestones have inspired countless festivals, rituals and myths across cultures. The orbit itself is shaped by gravity, the invisible force that binds the solar system together. The Sun's immense gravity keeps Earth on its path, while the gravitational tugs of other planets cause subtle wobbles and variations. These influences can shift Earth's orbit slightly over long periods, contributing to natural climate cycles known as Milankovitch cycles, which have played roles in ice ages and warming periods throughout Earth's history. From a human perspective, this yearly journey governs more than just the weather. It's woven into the fabric of our lives, our traditions, our harvests, our celebrations of birth and renewal. It structures the rhythm of school years, holidays, and the flow of nature's bounty. It reminds us that, just like the Earth, we are part of a larger cycle, turning steadily through time. Even with all our technology, we remain tied to this ancient rhythm. Satellites and telescopes orbit Earth and beyond, but the foundational rhythm of days and years remains rooted in our planet's path around the Sun. When we look at a calendar, plan for the seasons, or watch the sunset earlier each evening as autumn approaches, we are feeling the pulse of this orbit. As you lie quietly now, consider the vastness of this cosmic voyage, the Earth speeding through space at roughly 67,000 miles per hour, circling its star in a slow, majestic arc. This journey carries every mountain, every ocean, and every living being, including you, on its timeless path. And as the planet moves along this invisible track, the universe keeps time with it, marking the passage of years in the endless dance of light and shadow. So let yourself drift with this cosmic rhythm, feeling the deep connection between your own moments and the grand journey of the Earth around the Sun. In this way, time becomes more than just minutes on a clock. It becomes a beautiful living cycle, part of the very fabric of the universe. Among the countless stars scattered across the night sky, some shine with a rhythm that is unlike any other. These are pulsars, the universe's own precision timekeepers, cosmic lighthouses that pulse with a steady beat, marking time on scales both vast and precise. Their existence was a surprise to astronomers when first discovered, but since then, pulsars have become some of the most fascinating objects in the cosmos, revealing secrets about time, gravity, and the very fabric of space itself. A pulsar is a type of neutron star, born from the dramatic death of a massive star. When such a star exhausts its fuel, it collapses under its own gravity and explodes in a supernova, leaving behind a dense, compact core. This core is incredibly small, just about 20 kilometers in diameter, but it packs more mass than our Sun. The matter inside is so compressed that it forms a star made almost entirely of neutrons, held together by forces we barely understand. What makes a pulsar truly special is its rotation and magnetic field. After its birth, the neutron star spins rapidly, sometimes hundreds of times per second, and emits beams of electromagnetic radiation from its magnetic poles. Because the magnetic axis is not perfectly aligned with the rotation axis, these beams sweep across space like a lighthouse beam sweeping over the sea. When one of these beams crosses Earth, we see a pulse of light or radio waves, arriving with remarkable regularity. This rhythmic flashing is so precise that some pulsars rival atomic clocks in their accuracy. Imagine a beacon blinking perfectly every millisecond or second, uninterrupted for millions of years. Astronomers use these pulses to measure time intervals with astonishing precision, often to within a few billionths of a second. In fact, pulsars have become natural laboratories for testing theories of physics under extreme conditions. Pulsars help us understand gravitational waves, the ripples in space-time first predicted by Einstein's theory of general relativity. By carefully timing the pulses from pulsars in binary systems, where two neutron stars orbit each other, scientists can detect tiny variations caused by gravitational waves passing through space. This method has provided some of the most compelling indirect evidence for these waves long before detectors like LIGO were built. Some pulsars spin incredibly fast, known as millisecond pulsars, reaching rotation rates of hundreds of times per second. These speedsters likely gain their rapid spin by stealing material from a companion star, spinning faster and faster in a process called recycling. Such pulsars are cosmic metronomes, their rapid beats providing clues about the evolution of stars and the dynamics of binary systems. Beyond timing, pulsars serve as navigational beacons for spacecraft. Because their pulses are so predictable and unique, spacecraft equipped with sensitive detectors could, in theory, use pulsars to determine their exact location in space, similar to how GPS satellites help us find our way on Earth. This idea of a pulsar-based navigation system could one day guide astronauts on deep space missions far beyond our solar system. Pulsars also challenge our understanding of matter under extreme conditions. The intense gravity inside neutron stars crushes matter to densities far beyond what we can replicate on Earth. Studying pulsars allows physicists to explore the behavior of nuclear matter, magnetic fields billions of times stronger than anything created in laboratories, and the interactions between gravity and quantum mechanics. Though pulsars are distant and often invisible to the naked eye, their steady, silent ticking connects us to the deepest rhythms of the universe. They're reminders that time is not just a human invention, but a fundamental property woven into the cosmos itself. In their precise pulses, we hear echoes of the birth, life, and death of stars. A cosmic heartbeat that has been ticking for millions, even billions of years. So the next time you gaze at the night sky, remember that among those countless points of light are stars beating with a cosmic metronome, marking the passage of time in a way both ancient and astonishingly precise. These pulsars are the universe's own clocks, keeping time in the vastness of space, with a rhythm that quietly guides our understanding of everything, from the smallest particles to the grandest cosmic events. Light is more than just something we see. It is a messenger carrying stories across the vast emptiness of space and time. When we gaze at the night sky, the twinkling stars and distant galaxies we admire are not present as they are now, but as they were long ago. That's because light travels at a fixed speed, a cosmic speed limit, and it takes time for its journey to reach us. In this way, light itself becomes a natural clock, allowing astronomers to measure both distance and time across the universe. The speed of light is astonishingly fast, about 299,092 kilometers per second, or nearly 186,082 miles per second. Yet despite this incredible velocity, the universe is so vast that light from distant stars and galaxies can take years, centuries, or even billions of years to arrive at Earth. This delay means that when we look up at the night sky, we are looking back in time, seeing objects as they were when the light left them, not as they are at this very moment. This concept is both humbling and magical. For example, the sunlight that warms your skin began its journey about 8 minutes ago, travelling the 150 million kilometres from the sun to Earth. That means the sun you see is actually a glimpse into the past, a moment frozen 8 minutes ago. When we look at the nearest star beyond the sun, Proxima Centauri, we see light that left it over 4 years ago. The farther we look, the deeper back in time we see. Astronomers use this property of light to measure cosmic distances using the concept of a light year. The distance light travels in 1 year. The light year becomes both a distance and a time measurement, a reminder that the farther we look, the further back we see. This helps scientists map the universe and understand its vast scale. But light doesn't just travel in a straight line. It carries information encoded in its waves. Different colours, intensities and patterns reveal the composition, temperature and movement of distant objects. By studying this light through spectroscopy, astronomers can read the chemical fingerprints of stars and galaxies, determining what they are made of and how they change over time. Light also allows us to see the expansion of the universe itself. When astronomers observe distant galaxies, they notice their light is shifted toward the red end of the spectrum, a phenomenon called redshift. This shift happens because the universe is expanding, stretching the space between galaxies and the light travelling through it. Measuring this redshift gives clues about how fast the universe is growing and how old it is. Because light carries both distance and time, it serves as a cosmic clock, telling us the story of the universe's past. When we observe a galaxy a billion light years away, we see it as it was a billion years ago, a young, developing system long before our solar system even existed. This allows scientists to piece together the history of cosmic evolution, how stars formed, how galaxies grew, and how the universe transformed from a hot, dense beginning to the vast cosmos we inhabit today. Light's journey across space is not always smooth. It can be bent by gravity, a process known as gravitational lensing, where massive objects like galaxies warp the fabric of space-time and redirect light around them. This bending can create multiple images of the same distant object or magnify it, allowing astronomers to see things that would otherwise be invisible. Such lensing is a tool to study dark matter and the distribution of mass in the universe, adding another layer to how light reveals the hidden structure of space and time. In practical terms, the constant speed of light sets the ultimate limit on how fast information or signals can travel, influencing everything from the design of spacecraft communication to the theories of physics that govern the cosmos. It also reminds us that time and space are intertwined. The universe is not simply a backdrop. but a dynamic, evolving stage where light and matter dance together in an intricate balance. When you look up at a starry sky, remember that every sparkle is a story travelling across unimaginable distances and vast stretches of time. Light is the universe's messenger, bringing history to our eyes, allowing us to connect with events that unfolded long before humanity existed. Through light, we glimpse not just the present, but the grand, unfolding timeline of the cosmos, measured in beams of ancient photons travelling steadily through the night. In this way, light does more than illuminate. It measures, it marks, and it keeps time, turning the vast emptiness of space into a cosmic clock, ticking in rhythms written in waves of radiant energy that have journeyed across the stars to reach us. As human civilization advanced, our desire to measure time with greater precision grew ever stronger. The rhythms of nature, the cycles of sun, moon, and stars, were reliable but imperfect. Days vary slightly in length, seasons shift gradually over centuries, and even the most stable natural clocks have subtle inconsistencies. To navigate growing societies, trade, science, and eventually space exploration, we needed instruments that could keep time with extraordinary accuracy. This quest led to the development of atomic clocks, devices that harness the regular vibrations of atoms to create the most precise measurements of time ever achieved. Unlike traditional clocks, which rely on the mechanical motion of gears or the swinging of pendulums, atomic clocks use the natural oscillations of atoms themselves. Atoms, the tiny building blocks of matter, have electrons that jump between energy levels at fixed frequencies when exposed to certain electromagnetic signals. These transitions happen with a remarkable consistency, unaffected by temperature, pressure, or magnetic fields in carefully controlled environments. By measuring these oscillations, atomic clocks can divide time into intervals so stable that they lose only a second over millions of years. The most common atoms used in these clocks are cesium and rubidium. The cesium atomic clock, developed in the mid-20th century, became the international standard for defining the second. It is based on the frequency of microwave radiation that causes electrons in cesium atoms to change energy states precisely 9,192,631,770 times per second. This number now defines the official length of a second in the International System of Units, SI. The incredible precision of atomic clocks has revolutionized how we understand and use time. Atomic clocks are at the heart of technologies that govern our daily lives. The Global Positioning System, GPS, which guides navigation apps on smartphones and enables precise location tracking worldwide, depends on a network of satellites equipped with atomic clocks. These clocks keep time synchronized to within billionths of a second, allowing GPS receivers on Earth to calculate positions by measuring the time signals take to travel from satellites to the receiver. Without atomic clocks, GPS would lose accuracy rapidly, making navigation unreliable. In astronomy, atomic clocks allow scientists to coordinate observations between telescopes spread across the globe, combining their data with exact timing to create images of distant galaxies, black holes, and other celestial phenomena. This technique, called Very Long Baseline Interferometry, VLBI, relies on the precise timing provided by atomic clocks to link signals captured thousands of kilometers apart, effectively creating a telescope as large as Earth itself. The quest for even greater precision led to the development of optical lattice clocks and other advanced types, which use lasers to trap atoms and measure transitions at even higher frequencies. These clocks are pushing the boundaries of timekeeping, promising accuracies so fine they may soon detect tiny effects predicted by relativity or subtle changes in Earth's gravity. Atomic clocks also deepen our understanding of fundamental physics. Because time and space are intertwined in Einstein's theory of relativity, measuring time precisely can reveal how gravity and motion affect its flow. Experiments using atomic clocks on airplanes and satellites have confirmed that time moves differently depending on speed and gravitational potential, a phenomenon known as time dilation. These insights not only affirm our theories of the universe, but also have practical applications in satellite communication and space travel. In a poetic sense, atomic clocks are the bridge between the cosmos and the microscopic world, connecting the vast cycles of planets and stars to the tiny vibrations of electrons within atoms. They allow humanity to measure time with a clarity and stability that echoes the steady heartbeat of the universe itself. As you listen and let your mind wander among the stars, imagine the invisible ticking of countless atoms vibrating in unison, creating a cosmic rhythm that synchronizes satellites, guides explorers, and deepens our grasp of time's nature. These atomic pulses are a silent harmony underlying the vastness of space and the precision of human endeavor. A quiet but powerful reminder that time is both infinite and exquisitely measurable. Through the mastery of atomic clocks, we have learned to keep pace with the universe's unfolding story, marking each moment with a fidelity once thought impossible. This precision is more than science. It is a testament to human curiosity and the timeless desire to understand our place in the grand cosmic dance. Time is not the fixed, unchanging river we often imagine it to be. Instead, it is a fluid, flexible dimension, interwoven with space itself, shaped by gravity and motion in ways that challenge our everyday experience. This profound insight comes from Albert Einstein's theory of relativity, which revealed that time can stretch and compress, slow down or speed up, depending on how fast you move or how close you are to a massive object. This concept, known as time dilation, transformed our understanding of the universe and the nature of time itself. Imagine travelling at nearly the speed of light, an impossible feat with today's technology, but a thought experiment that reveals time's surprising behaviour. According to Einstein, as you move faster and faster, time for you slows relative to someone standing still. If you could board a spaceship and travel close to the speed of light, you might experience only a few hours passing, while decades or centuries unfold back on Earth. This phenomenon isn't just theoretical, it has been confirmed in experiments using particles moving at high speeds and precise atomic clocks flown around the world on airplanes. Time dilation also occurs near massive objects like black holes. Gravity isn't just a force pulling objects together, it warps the fabric of space and time around it. Near a black hole's event horizon, the point beyond which nothing can escape, time slows dramatically compared to an observer far away. To someone watching from a distance, a clock near the event horizon would appear to tick more and more slowly, almost freezing in time. For the person near the black hole, time would continue normally, but their experience of reality would differ drastically from anyone observing them. This strange warping of time has deep implications. It means that time is not an absolute backdrop on which events unfold, but a dynamic dimension influenced by motion and gravity. Space and time are woven together into a single fabric called space-time, and massive objects cause this fabric to curve. This curvature guides the paths of planets, light, and even time itself. Einstein's insights challenged centuries of Newtonian physics and reshaped how scientists think about the universe. They revealed that clocks in different gravitational fields, or moving at different speeds, do not measure the same time. This realization affects everything from GPS satellites, which must account for time dilation due to both their speed and altitude, to the understanding of how the universe began and how black holes behave. The interplay of time and space also raises philosophical questions about reality. If time flows differently, depending on your frame of reference, what does that say about the nature of now? Can two observers disagree about the sequence of events? These questions touch on the deep mysteries of causality and the structure of the universe, reminding us that time is far more complex than our daily experience suggests. On a more poetic level, time dilation reveals the universe's layers of hidden rhythms. While we live with a steady heartbeat of seconds and minutes, somewhere out there in the cosmos, time stretches and contracts, folds and bends, a dance choreographed by gravity and speed. It is a reminder that time is not merely a human invention, but a fundamental aspect of reality, flexible and alive. As you relax now, imagine floating near a massive star or hurtling through space at unimaginable speeds. Feel time stretch and bend around you, flowing differently than on Earth. This cosmic flexibility is part of the universe's profound mystery, a secret rhythm that governs not only stars and galaxies, but every moment you live. In understanding time dilation, we glimpse the universe's deeper nature, where time is no longer a rigid arrow, but a malleable thread woven into the grand tapestry of existence. This knowledge invites awe and wonder, opening our minds to the beautiful complexity of the cosmos and our place within its ever-changing flow. High atop mountains, deep within deserts, and orbiting far above Earth's atmosphere, observatories stand as humanity's vigilant eyes on the cosmos. These dedicated places of observation and discovery serve as essential tools in our quest to understand the vastness of time and space. Through powerful telescopes and sensitive instruments, observatories capture the faintest light and subtle signals from distant stars, galaxies, and other celestial phenomena, allowing us to read the universe's story with ever-increasing clarity. From ancient times, people have gathered in places specially chosen to observe the sky. Early astronomers selected mountaintops or clear deserts for their minimal light pollution and steady air, creating simple structures aligned to the movements of the sun, moon, and stars. Today's observatories continue this tradition, but with technological marvels far beyond what our ancestors imagined. Modern observatories use large, sophisticated telescopes capable of detecting not just visible light, but also radio waves, X-rays, infrared, and other forms of electromagnetic radiation. Each wavelength reveals different aspects of the universe. Some show the hot cores of distant galaxies. Others peer through cosmic dust clouds where stars are born. and some even detect mysterious phenomena like pulsars or black holes. By combining these perspectives, astronomers gain a multi-dimensional understanding of the cosmos and the passage of time within it. One of the key roles of observatories is to monitor the regular patterns and changes in celestial objects, which act as natural clocks. They track the rotation of stars, the pulsations of variable stars, the orbits of planets, and the timing of eclipses. These observations allow scientists to calibrate other timekeeping methods and understand the complex interplay of celestial mechanics. Observatories also play a crucial role in studying transient cosmic events, phenomena that occur suddenly and often unpredictably, such as supernovae, gamma-ray bursts, or the merging of neutron stars. These explosive occurrences not only light up the skies but also provide invaluable information about the life cycles of stars and the evolution of galaxies. Timing these events precisely helps astronomers probe the physical laws of the universe and test theories about its origin and fate. The most advanced observatories are not limited to Earth's surface. Space-based telescopes orbit above our atmosphere, free from the distortion and absorption caused by air and weather. The Hubble Space Telescope, for example, has revolutionized astronomy by providing sharp, clear images of distant galaxies and nebulae, some of which are so far away that their light has traveled billions of years to reach us. More recently, observatories like the James Webb Space Telescope peer even deeper into the universe's past, capturing the faint glow of the earliest stars and galaxies, giving us a glimpse of time near the universe's beginning. These observatories operate like cosmic time machines. By collecting light and other signals that have travelled for millions or billions of years, they allow us to look back into epochs long gone. Each photon they detect is a messenger from a different era, telling stories of creation, destruction, and transformation across the ages. Collaboration is another hallmark of modern observatories. Worldwide networks of telescopes synchronize their observations, using techniques like very long baseline interferometry, VLBI, to effectively create giant virtual telescopes with extraordinary resolving power. This collective effort lets scientists measure minute changes in the positions of celestial objects and track their movements with exquisite precision, revealing new details about cosmic time and structure. Beyond their scientific function, observatories inspire wonder and curiosity. They remind us of humanity's deep-seated desire to understand the universe and our place within it. Standing beneath a telescope pointed toward the heavens, one feels connected to generations of stargazers who looked up with awe and questions. As you settle into calm and quiet, picture yourself in an observatory's dome, watching the night sky through a giant telescope. Feel the steady patience of astronomers, waiting for the faint signals of distant worlds. Know that through these instruments, the universe speaks its ancient language, sharing the passage of time encoded in light and gravity. In this way, observatories are bridges between Earth and the cosmos, tools that transform the silent, distant universe into a living story of bitter motion and mystery. They are gateways to understanding how the heavens keep time and how, in turn, we too are part of this grand cosmic rhythm. Black holes are among the most mysterious and extreme objects in the universe, regions where gravity is so intense that nothing, not even light, can escape once it crosses a boundary known as the event horizon. But beyond their dramatic nature, black holes profoundly affect time itself, warping it in ways that challenge our very understanding of reality. Imagine approaching a black hole, the invisible boundary looming ahead. For an observer far away, watching from a safe distance, time near this boundary seems to slow down dramatically. A clock moving closer to the black hole's event horizon would appear to tick more and more slowly, as if time was stretching and nearly freezing at the edge. This effect arises because the immense gravity of the black hole bends space-time itself, causing time dilation of an extraordinary scale. For someone falling toward the black hole, time would feel normal. They would not notice this slowing, but their experience of the universe beyond the black hole would be different. To the distant observer, the falling person's movements would seem to freeze, suspended in a moment that never quite passes. This strange stretching of time near a black hole means that what looks like seconds or minutes to the falling person could correspond to years or centuries outside. This extreme warping of time is a direct consequence of Einstein's theory of general relativity, which describes gravity not as a force pulling objects, but as the curvature of space-time caused by mass and energy. Black holes represent points where this curvature becomes infinitely steep, creating a valley in space-time so deep that escape becomes impossible. The concept of time behaving differently near a black hole challenges our intuition and reveals the complex nature of time as a dimension tied to space. It shows us that time is not a universal constant, but can be stretched and distorted by gravity, especially in extreme environments. This realization has profound implications for our understanding of the universe, suggesting that time itself is flexible and subject to cosmic forces. Black holes also raise questions about the fate of information and matter that crosses the event horizon. According to classical physics, anything falling in is lost forever. But modern theories involving quantum mechanics and black hole thermodynamics suggest that information may somehow be preserved, stored, or transformed at the boundary, ideas that continue to intrigue physicists and spark debate. Beyond their influence on time, black holes serve as cosmic laboratories for testing the limits of physics. Observing phenomena such as accretion disks, matter spiraling into the black hole at near light speed, and the powerful jets ejected along its poles allow scientists to study how matter behaves under extreme gravity and how space-time itself responds. The interplay of time and gravity near black holes also connects to broader cosmic mysteries, including the nature of singularities, points of infinite density, and the possible existence of wormholes, hypothetical tunnels through space-time that might allow travel between distant points or even different times. As you reflect on the vastness of the universe, consider the strange realm near a black hole where time slows to a crawl, where moments stretch into eternity, and where the familiar flow of past, present, and future becomes blurred. This is a place where the universe's deepest secrets reside, hidden in the fabric of space-time itself. In your quiet moments, imagine drifting near such a cosmic giant, feeling time's slow dance around you, stretched and twisted by gravity's invisible hand. It is a powerful reminder that time, while often measured by clocks and calendars, is also a living, bending dimension, one shaped by the mass and energy of the cosmos, revealing the extraordinary depths of reality beyond our everyday experience. The universe itself is not a static place. It is expanding, stretching the very fabric of space over unimaginable distances. This expansion began with the Big Bang nearly 14 billion years ago and continues today, shaping how galaxies drift apart and how time unfolds on the grandest scales. This cosmic growth creates a rhythm of its own, a subtle but powerful shaping of time across the vast reaches of space. Imagine the universe as a giant balloon being slowly inflated. Galaxies, stars, and clusters of matter are like dots on the surface of this balloon, moving away from each other as the surface stretches. This stretching doesn't happen because galaxies are moving through space like cars on a highway, but because space itself is growing between them. As space expands, the distance between galaxies increases, carrying time along with it. This expansion affects the passage of time in ways that are both profound and fascinating. Because light must travel through this stretching space to reach us, the light from distant galaxies becomes red-shifted, its wavelength stretched toward the red end of the spectrum. This redshift tells astronomers how fast galaxies are receding and reveals the universe's growth rate, a value known as the Hubble constant. By measuring this, scientists can peer back into the universe's history and understand its age and destiny. The expanding universe also means that time flows differently depending on where you are and how far away you look. Observing distant galaxies is like looking back in time, seeing them as they were billions of years ago, shortly after the universe's birth. The further we look, the deeper into the past we see, a cosmic layering of time itself, woven into the fabric of expanding space. On a grand scale, the universe's expansion is intertwined with its energy content. Dark energy, a mysterious force driving the acceleration of this expansion, influences how time and space evolve together. This discovery, one of the most surprising in modern cosmology, suggests that the universe's future may be shaped by this accelerating growth, stretching space and time faster and faster. This stretching of space-time also impacts the flow of cosmic events. Galaxies that once seemed destined to collide may drift apart instead, forever out of reach as the expansion pushes them away faster than light can travel between them. This leads to the concept of the observable universe, a bubble of space from which light has had time to reach us. Beyond this horizon, galaxies recede too quickly for their light ever to arrive, placing limits on what we can know and observe. The expansion of the universe is not uniform at smaller scales. Gravity holds galaxies and clusters tightly together, creating islands of matter that resist the stretching of space. Within our own Milky Way, stars orbit each other in stable paths, unaffected by the cosmic expansion. This interplay between local gravitational attraction and the overall expansion creates a delicate balance that shapes the large-scale structure of the cosmos. Philosophically, the expanding universe invites reflection on the nature of time itself. If space stretches endlessly, carrying galaxies apart, how does this affect the flow of time on a universal scale? It suggests that time is not simply a linear sequence, but is linked intricately with space, together forming a dynamic, evolving whole. This view challenges the notion of an eternal, unchanging present and points toward a universe where past, present, and future are woven into the ever-expanding fabric of reality. As you rest now, imagine the universe growing around you, a cosmic breath expanding silently in the dark. Galaxies drift apart, stars are born and fade, and time stretches like the fabric beneath them. This immense, unfolding process connects every moment you experience to the grand story of space and time, reminding us that we are part of a living, expanding cosmos. In this vastness, the passage of time becomes more than just hours or days. It becomes the heartbeat of an ever-growing universe, a rhythm written in the stretching of space itself, a timeless dance of creation, change, and endless possibility. Right now, at this very moment, you are an intrinsic part of a cosmic dance that began billions of years ago, a rhythm of time and space that connects every atom in your body to the stars themselves. The universe's clock has been ticking since its fiery birth, and your existence, brief as it may seem, is woven into this vast, unending flow. It is humbling and beautiful to consider that the elements composing you were forged in the hearts of ancient stars long before our sun ever shone. Your place in this grand cosmic clock is unique and precious. Though the universe spans unimaginable distances and timescales, it is here, in your life, your moments, your breath, that time becomes deeply personal and meaningful. You are a single beat in a much larger rhythm, a point where the vastness of cosmic time converges with the intimate flow of individual experience. Every moment you live is part of a cycle far older and more intricate than any human calendar or clock. Your days follow the Earth's rotation, your years trace its path around the sun, and your life unfolds within the vast timeline of the cosmos. You carry within you the legacy of countless generations, all moving through time like you, marked by change, growth, and the steady passage of moments. In a way, time's grand scale offers comfort and perspective. When challenges arise, or when the weight of the day feels heavy, remember that you are part of a cosmic rhythm far greater than yourself. The stars that light the night sky have witnessed eons of history, cataclysms, births, and quiet moments, and through it all, the universe keeps time without rush or pause. This connection to cosmic time also invites a sense of wonder and curiosity. The universe's story is still unfolding, and you're a participant in its ongoing creation. The choices you make, the moments you cherish, and the life you live ripple outward in this vast flow. Though your time is brief on a cosmic scale, it is vibrant and significant in the human story. Your own experience of time, its joys, sorrows, pauses, and bursts, is part of the universe's unfolding narrative. Time is both universal and deeply personal, a river that carries stars and souls alike. This duality invites reflection. While we are shaped by the cycles of nature and the universe, we also give time meaning through our stories, relationships, and moments of awareness. As you rest and prepare for sleep, imagine yourself as a thread in the cosmic tapestry, woven through the fabric of space-time. Feel the gentle pulse of the universe's heartbeat beneath you, the slow, steady tick of stars forming and fading, planets spinning, light travelling across vast distances. and time stretching endlessly forward. You are not separate from this immense dance. You are part of it, a luminous spark in the grand clockwork of the cosmos. And as you drift into rest, know that time's flow continues, welcoming you, carrying you, and embracing you as part of its infinite rhythm. So tonight, surrender to the cosmic lullaby. Let the universe's vast and gentle timing soothe you. Rest peacefully within this grand story, where every second you live is a precious note in the endless symphony of time.